In 34, we're going to do parts A and B. And the first part it's asking what the boundary points of a deleted neighborhood of a complex number is. So just a quick reminder, a deleted neighborhood is the set of points z and c such that the distance between z and z naught is strictly less than some number. Usually we write epsilon, or I think perhaps your book uses rho. It doesn't matter what we pick. Let me keep with the book's notation and call it rho. Now, without sorry, I keep writing these bars. It's a habit. I should do a colon instead. Without we're not done yet. I haven't defined what the deleted neighborhood is yet. But if we just had it here, what we would do is we would draw the complex plane. We would figure out wherever z naught was. We would draw a ball of radius rho about z naught, and then we would shade that area in with whatever color. So that's that. Now with a deleted neighborhood, you take that and then you get rid of the center. How can you get rid of the center? Well, you force z to be not equal to z naught, right? I had you do in class, the modulus of a complex number is 0, if and only if that number is 0. So z is going to be equal to z naught if and only if the modulus is 0. So by forcing this inequality that the modulus of z minus z naught is positive, it has the effect of creating a hole in the middle. So there's a hole here. That's not a very good color. Let's use black. There's a hole now. We've gotten rid of it. But it's kind of an infinitely small hole. Okay, so this is the deleted neighborhood of z naught. And this question is asking what are the boundary points. Now, it's tempting to say that z naught itself is a boundary point, but to be a boundary point, you have to have a point which is inside the region and outside the region that's not equal to u. So we can't pick z naught to be the point outside the region because we're not allowed to pick us as the outside point. So z naught is not actually a boundary point. So let's just mark this. Z naught is not on the boundary. And this should make geometric sense. If we've defined boundary correctly, and boundary means what we think it should mean, z naught has no business being on the boundary. It's very much interior to the shape. Okay. However, there is a bounding circle. The boundary points, in this case, is a contour, so a nice smooth shape. Boundary points are, so here's our deleted neighborhood, and the boundary points are the collection of points where we're on the circle. So that's, I keep drawing the bar, sorry. That's where the modulus of z minus z naught is exactly rho. We're exactly on the circle. And so these points are not in the original shape. We would have to sort of add them to close off our set. But anyway, the boundary points for this guy are here. So there we go. Now for the next example, so the next part of 34, we're asking what are the boundary points of all of C? So I think it's helpful here to draw a picture. I have to, according to what we just did, I have to draw all of C. So here's all of C. And then once we've shaded everything that we can see in, we've gotten all of C. And then what we have to do is we have to ask ourselves, are there any points in C that have nearby points that are both in C and not in C? And everything is in C. So of course the answer is no. So there is no boundary. And this should also agree with our intuition. C shouldn't have a boundary because that would mean we could sort of fall off of C at some point if we added those points in. But C is, it's the expanse. It continues forever in each direction.